Alright guys, welcome you back to my YouTube channel. Hey, the name's Sal Junior Nelson, taking you through an AI project called the Artificial Intelligence Written Text Symbol Recognition. I'm a student at Makerere University pursuing a bachelor's degree in computer science. So, starting with the problem to be investigated, which I've kept on describing since I began working on this project. So the problem is simply like it's more about forgery, as someone may write something that is maybe not understood, then using the modem to train transforms it into machine readable text such that the real thing that that person has written down can come out. So this is the problem statement, which is to transform the handwritten text into digitized text zero, which will increase the processing speed, accuracy, false detection, and this will be done by scanning of the document. Then, with this presentation, I'll be taking you through the heat map, the correlation matrices, the box plots. So starting with the heat map. Under the heat map, to generate this heat map, I simply used some code base, which I will show you at the end of this presentation, which I wrote in the Jupyter notebook. It's done which generated this code base. But the heat map, it just simply it's just an analytical tool that is helping the user to understand the dataset, since the dataset contains a lot of components. So to simplify for the user, we represent it by the heat map. Then correlation matrices, I'm simply identifying those key variables which I'll use depending on the classes which are in my dataset. So for my dataset, the classes which are in there, they are the training, validation, and testing classes. Then the box plot, which is simply representing the first one, it's the train box plot, test box plot, and then lastly, it's the validation box plot. Simply displaying the distribution of database on validation data, train data, and test data. So the patterns of interest, as you know, if you're training a model, know that the model will not take all the data that you are inputting in it. All the data that you are inputting into that model will not be valid for it. So if I can give an example of you're training a model to identify people maybe with long-sleeved shirts in a class. So that model, the data for short-sleeved shirts, it will be an input data, but it will not be necessary in that case. So with exploring and cleaning of the data, it's all about getting the key variables from the data set and then representing them. But this was done in my Jupyter notebook from the code base. Then the dataset splitting. So my dataset, I split it into major three classes. Here you're seeing 4 classes, but they are majorly 3 classes, which is the test, train, and then validation. This simplifies the way in which I can interact with my dataset, since I've broken it into smaller pieces which I can easily handle. Then with the tune hyperparameters, I'm just simply referring to variables that are governing the training process. So in there are variables which may not be necessary during the training process. So with the tune hyperparameters, you're going to identify those variables that will be used in the training process, then ignore others for the test process and then validation. So with evaluation and the validation set, this is how I've evaluated my validation set with a simple representation. So I start by splitting the data set, which I described, then handling the class, which is the validation set class. I evaluate it depending on the data that is in there to test my model. So guys, these are the references to my research work. But before I finish up with this, I want to show you the code base, how I generated the heat map, the correlation matrices, the box plots, and so on. Coming to our Jupyter notebook, this is just my Jupyter notebook in which includes my code base. So I have my Excel sheet which had sample data from the data set. So first of all, starting with the correlation matrices, which I said it's simply identifying the key variables from my data set and then displaying them. So this is how I displayed. I first imported Panda, import Panda as PD. If you say just import Panda, it means on this line 10, you have to use panda.read Excel. But since I've imported it as PD, I'm simply using PD. Then this is the directory for my of my Excel sheet that's containing the data I'm representing here. So with simply that's all about correlation matrices. Then coming to the representation of the correlation matrices itself, it's here where I'm representing the training data, validation data, and test data as data accuracies as I've shown. So this was just a repetition, but the idea is the same, just the colors. Coming to the box plot, you have to import multiplot.pyplot as PLT. So instead of using the multiplot I'll keep using the PLT wherever instead of these two save time. So I import numpy as NP. Then this is my sample data from the data set. So with creating a box plot, so here, this is BP standing for the box plot, then ax.boxplot, then the data. I'm inheriting this data. I'm inheriting the data from the data set. So starting with the box plot title, which is this represented here, then the labels. Then here I'm showing the box plot. So with the outliers representing the outliers, this is the code base for representing the outlier plots. So this is the variable. Then I've imported numpy as np, so that's why I'm using np.append arrow starting from like 27 to 30. So this is the range in which my array of the outliers should belong. So this is the I'm printing my array which is here, but before printing I start here with some title, which is the outline. Then I'm simply writing some Python function. This is some Python code, which is simply telling the IDE that it should move this other line, this other text, some text code to a new line, which is this. Then with the illustration of patterns of interest, this is the sample data from the dataset that I'm using. So these are the illustrations of the patterns of interest. So guys, thank you for watching the YouTube video. I think you enjoyed it, and I kindly request you to subscribe, like, and then comment. Thanks for watching.